So we're going to predict here whether a reaction will occur in each of the following cases. Okay, so the first part is to write ionic equations. Okay, and then the sulfate, and then the potassium, and the hydroxide. So right away you might think of magnesium hydroxide. Okay, and so we're thinking of this. And potassium sulfate. Okay, so we know that most hydroxides are insoluble. Exceptions: ammonium and group 1A metals, salts. Okay, so exceptions are group 1A metals. Let's see if magnesium is in 1A. No, it's not. Magnesium is in group 2A. Right? So it means that it's going to be insoluble. This compound is insoluble. Therefore it will be a solid. Right? Which means it will be a precipitate. Right? Let's check this one. This one is potassium sulfate. Okay? Most sulfates are soluble. Exceptions are four ions in which potassium is not listed, right? So this is going to be still aqueous. Okay, so in other words, these two ions will be still aqueous, right? They will not form a solid, right? They will still be in the form of solution. So the net ionic is going to be this, right? So on one side we can write this, and that's a solid because that's a precipitate, right? And on the left side I'm going to write the ionic, 2 plus aqueous plus the hydroxide. Now we have to balance, right? So we have to write a coefficient 2. Okay, and we're done. So there's a reaction. Part B. Let's write in ionic form. Then the nitrate. No, sorry, I was going to write the chlorine. Okay, we have to write the coefficient 3. Okay. So that means, so let's see, yeah, and then the 2, and then the sulfur, okay. So you might think it's going to be iron sulfide right away, right? So in other words, I'm thinking of this and this as a compound being formed. I wrote 3 here because for 3 sulfur ions you will have 2 iron ions, right? Because of the numbers here. Okay, so that's 1, and the other one is sodium chloride. Okay, and again this one will be, so well, we don't need to worry about the numbers because sodium chloride is not going to be insoluble, it's going to be soluble, right? So this is not going to be a precipitate. But let's check this one, whether or not this is true. Let's see, so we need a sulfide, right? So most carbonates, hydroxide, phosphates, and sulfides are insoluble. Exceptions: ammonium and group 1A metals, metal salts, group 1A. Now iron is not in group 1A. Iron is group 8B, right? So this is definitely going to be true. This is going to be a precipitate. This is going to be the reaction. And this is going to be aqueous ions. These two ions will remain aqueous, right? So the net ionic is going to be this. Is going to be this, Fe2S3 solid. Now one more thing that you need to do, one more thing is to balance, right? So there are two atoms here of the iron, right? So we will well, we will say it's ions, so we will put 2 there, and there's a 3 for the sulfur ion, right? So we're going to put a 3. Right now it's balanced. Alright, and this is going to be the precipitate, right? So far we have reactions in cases of A and B. Right, let's check the C. So again, writing in ionic form for the strontium, for the first element. And you should memorize these positive charges. I mean these charges for individual ions. You should memorize them, right? Some of them has positive, some of them have negative, right? Depends on the number of electrons lost or gained, right? And then plus, so this means that we have a coefficient for the nitrate. Then 2 coefficient for the sodium. And then sulfate ion. So now, so what comes to mind? What comes to mind is the strontium sulfate compound. Okay? And they happen to have the same number 2 and 2, even though their charges are different, but we don't need any more subscripts as a result, right? So this comes to mind, and something else. And this, right? This comes to mind as well. Now nitrate has 1 negative charge, right? So, and the sodium has 1 positive charge, right? So this is what it is. Now let's check the nitrate first. Almost all nitrates are soluble, right? And group 1A metal salts, right? And so there's nothing to indicate that the sodium nitrate will give us a solid result or a precipitate, right? They will remain in aqueous ions. Each individual ion will remain aqueous, right? However, let's check the strontium sulfate. Okay, strontium sulfate. So we know that most sulfates are soluble. Exceptions are strontium, right? So the SR, strontium, together with the sulfate will form a precipitate, right? So we have to write an ionic equation. So SrSO4 solid. Now let's balance. Do we need to balance? No, we don't actually, right? Because all the coefficients match, right? So this is going to be a net ionic equation. So as you can see in all three cases A, B, and C, we have a precipitate. We have a solid being formed in the aqueous solutions, right? Because first we break everything up into individual ions, right? And then we see which ions we can match with other ions that were not matched in the given left side of the reaction. Basically, you're looking at the reactants and you're trying to break them up into individual ions and then see what other products you could form by looking at the other pairings, right? Not already shown in the beginning, right? So as we can see, there are pairings that will produce precipitants in all three cases, A, B, and C, because we follow the rules of which compounds are soluble and which compounds are not, right? So that helps us determine the precipitates. Thanks so much for watching. Hope this was helpful, and I'll see you in the next video.